Good morning, and thank you for being here. My name is Danilo, and I'm part of the evangelist team in Amazon Web Services, and I'm specifically focused on serverless. I start to be quite impressed by serverless starting at the end of 2014 when we launched AWS Lambda, and all these serverless things started to ramp up. And I also wrote a book that has been translated to Chinese and Korean. And I also work with my publisher to have a free ebook. So the last one on your right is a free ebook on agile development for serverless. It's a collection of content that can help you start with the right foot. And what is serverless? So this is the mandatory definition slide. I like to think of serverless as a way of building application and managing application in production, so there is an impact on the development and on the operation side of the application, where you don't have to think about the underlying infrastructure. So, for example, you don't need to manage the servers, you don't need to patch them, you don't need to think about the scaling, so you can use your application once per month or 1,000 times per second, and the infrastructure will grow and shrink automatically. Everything is designed to be fault tolerant, so even if you created the most simple hello world application with serverless, it will be still automatically replicated across multiple data centers. So something that if you want to build it yourself is not that easy. And probably one of the most important effects of serverless, features of serverless, is that you pay only for value. So you pay if you use storage, you pay if you use computational resources because your code is executed, but you shouldn't pay if something is idle. And more recently, when I was talking about serverless with customers, they were telling me that normally they already have some minor experience with serverless. They already created, for example, a serverless function with AWS Lambda. They want to go to the next level. They want to build something more complex. So for example here, how many people created a function using, for example on AWS, they created a Lambda function, or with another provider? Okay, so that the assumption was correct. So let's see. So to go to the next level, I try to look into what our most successful customers are doing, what we're doing inside Amazon and inside AWS more specifically, to get a few suggestions that can help you grow into this path. Not everything is only serverless specific. Some of the things you can use them also with other development approach. And probably the stepping stone for building a good serverless application is to manage your infrastructure as code. So what I mean is that you should be able to describe the build-up of your infrastructure, what you need using text files. And that makes infrastructure change easily to be repeatable and predictable. So for example, if you want to destroy everything and rebuild everything, you can do that very quickly. You can release infrastructure changes together using the same tools that you use to release software changes. So in the same way you deploy a new version of your application, you should be able to deploy a new version of your infrastructure because maybe you need more power or a different configuration in your database. And you can also easily replicate your production environment, for example, to create a staging environment, or even just temporarily to create a performance test environment that you use maybe only for a few hours. You can do that because you have these text files. And some of the best practices are really that the code describing your infrastructure and the code of your application should be in the same repository. And in this way, the deployment include also infrastructure updates. So this is the new version of my application with the new version of my infrastructure. And there are different tools to do that. So for example, HashiCorp, they created Terraform, is a great tool. On AWS, we have CloudFormation that we created a few years ago that allows you to define your code using YAML or JSON files. So what about serverless? So I just said that serverless, you don't need to think about the infrastructure now and say, okay, but you need to manage your infrastructure as code. So in reality here I'm talking about a way to define the high-level resources that you need to build a serverless application. So for example, the Lambda functions, the database table, the storage buckets, and again, you want to define that in a text file so that you can easily implement this in multiple environments and roll out updates. CloudFormation could do that, but it was designed before serverless, so it's very verbose. So if you try to use, for example, CloudFormation to define a serverless application directly, it will be hundreds of lines of code. So for that reason, we released a few years ago in open source the serverless application model. It's a way to define a serverless architecture in a much simpler way. And there are, of course, other options. So, for example, a very popular one is the serverless framework. It's another open source project used by lots of our customers that is really interesting. So especially if you come from a scaffolding development environment where you use something like Ruby on Rails or Express.js, then the serverless framework is probably something that you will feel comfortable with. So talking about SAM, the serverless application model, it's a way to use YAML or JSON, if you prefer, to define all the high-level resources that you need to build your serverless application very easily. So these 20 lines of code, for example, define that there is a serverless function with some specific file name and function inside the file. The permission of the function. In the cloud, everything requires to have some permission. So this function needs to be able, for example, to read from a database table that is created in the same template. And the syntax that I used here is what we call policy templates. It's something that we launched 1 year ago. It was not there when we launched SAM. And it's a very nice way to define permission in the cloud. So normally what I experience is that permissions can be complex for a developer coming to a new environment like AWS. So policy templates can help you create good policies very easily, because in this way you just need to tell, I want to give read access to this database table, and then that means lots of different operations on the database. You can query, you can scan, you can go put read item by key, and all of this is translated by our policy templates automatically. We then say that the event triggering this function is an API gateway. This is an API, so we set up the API gateway because of that. And then there is the syntax of the resource for the REST API. And then we create the database table, the DynamoDB table that we want to read from this function. So very easy. And if we translate this to CloudFormation, it's much, much more verbose, because there's lots of underlying complexity that we simplify with SAM. And to use SAM efficiently, we also created an open source tool that is called the SAM command line interface, the SAM CLI. And it's super easy to install. It's written in Python, so you can use pip, but normally pip install can mess up with your Python installation, especially if you're using a MacBook. So look for we also have native installers that bring their own version of Python when you install it. Then you can do SAM init. I hope you can see it, because the screen is not huge. Can you see from the bottom? OK, perfect. Thank you. So SAM init. So I initialize my application. I want to use, for example, Python to create my serverless application. And this will create all the necessary files to start building your application. And then if you enter into the directory that is created, you can use tools like SAM local to invoke the function locally. We use Docker containers to emulate the Lambda environment, including the timeout and everything locally. You can invoke also the API locally, so we emulate the API gateway, and also the Lambda invoke API syntax locally with start Lambda. And you can also generate synthetic events. This is very useful if you want to set up some basic, not unit testing, but basic testing. This is not integration testing, but for example, you want to say, my function should react when a customer is uploading an image on S3. You can create a synthetic event of an S3 upload, and then create an automatic test that will use this synthetic event to test the result of the function with a local execution. So this will accelerate your development cycle locally. And then you can validate the template. So if you make changes, I want to add an S3 bucket, I want to change the configuration of a DynamoDB table, you can validate the syntax of the template. You can do the build and create the artifact. And then with package, we upload the artifact to an S3 bucket, storage, an object storage in the cloud. And then we can deploy the template in your application. And we normally say we create a stack out of this template, and the stack is the implementation of the template. And these 4 commands you can cycle as much as you want, because CloudFormation, that is under the hood, will compare what you want to build with what is already there. So if you want to continuously update your application, you can just iterate with these commands. You can use this SAM CLI, for example, with Jenkins, or with managed CI/CD tools. For example, on AWS, we have Code Pipeline that comes from an internal tools that we created in Amazon for internal usage, that is called Pipelines. And from that experience, we created Code Pipeline. And when the function is deployed in the cloud, you can also get the logs locally. So when a Lambda function is executed in the cloud, it is what is normally called a headless environment. There is no possibility to log in on the server. So all logs are collected by us into a platform that is called CloudWatch Logs. But you can use, if you want, this quick command semlogs to get the logs of your function. So if you're debugging quickly, for example. And you can also use -t to tail the logs from the cloud locally. So it's a very good way to test the remote execution locally and tail the logs and see what happens when the function is invoked. And you can also publish this into an application repository that we created to share serverless application. You can share this application privately within your company, for example, or publicly with everybody if you created something that everybody can reuse. So, and to make this even more interesting, we introduced the concept at the end of last year of nested serverless application. So let me make an example of this. When we talk with our customer, we found that there are some recurring problems that lots of customers have. And then we find that there's some customization that each customer is doing differently. So for example, one thing that lots of customers is asking us is, I want to monitor social media. For example, I want to monitor if on Twitter, my brand, my products are mentioned. And this is very, very common. But then every customer wants to do something differently. So some customer, they want to just take the tweet that mentioned their products and store them, and then they run maybe analytics. Other customer, they want to run sentiment analysis on the tweets, and if the tweet is negative on their product, then they route the tweet to their customer support so that they can quickly act and maybe get in touch with the customer. So here, if you want to build this in a serverless way, it's super easy. So you can use, for example, CloudWatch events to trigger a Lambda function periodically, for example, every minute or every 5 minutes. The Lambda function can use the Twitter API to search for a specific string. And the Twitter API return a checkpoint every time you do the search. You can store the last checkpoint of your search on a DynamoDB table that will have one single item, just the last checkpoint. And then when you found tweets about your product, you call another Lambda function that is the Twitter processor that will act on those tweets. So we'll store them, we'll analyze them, we'll route them to the customer support. So here we have a standard component that is common to lots of our customers. And then there is the unique business logic that each customer wants to do differently, the Twitter processor function. So what we did, we said, okay, let's take the standard component, let's transform it into a serverless application that can be nested inside a more general application. So in the same syntax, what happens is that inside your template, together where you define this is a function, this is a database table, you can say, I want to embed an application inside my application. This is the application ID, this is the semantic version that I want to use. This application is stored in the application repository. And then you can pass parameters. For example, you say, this is the string that you need to search on Twitter, and this is the function that you need to call if you find tweets about this string. So in this way, you really don't have to write one line of code that is not your unique business case. Everything else is a standard component that you can recycle. But infrastructure as code is something that is still in development. And there's more recently some people that were asking about, can we use infrastructure with real code? So the code that I use to build my application. No? Because sometimes there's jokes of people saying this is actually infrastructure as YAML, not as code. And we start to think about that, and last year we launched this project that is still in developer preview, and the idea is to use your own programming language to define the infrastructure. It's called the Cloud Development Kit, the CDK. And you can install it with npm, and then you have the CDK command line interface that you can use to initialize your application. You can use these languages for now. These are the ones that we support, so TypeScript, C# and F#, Java, and Python. This is not the language that you have to use to build your application. This is now the language that you use to define your infrastructure. Probably it's the same, because nobody wants to mix things too much, but it can possibly be different. And then you can synthesize this application from the Python TypeScript language into CloudFormation syntax. You can deploy the application in the cloud. If you edit this template locally with your own language, you can compute the difference. So for example, you can say, okay, locally I have this configuration, in the cloud there is this configuration. If I do a deployment, these will be the changes that will be implemented. Or you can destroy the stack in the cloud. So, and you can use this command line tool with Jenkins or with a managed service for CI/CD like CodePipeline. So let's see how this works. So this is an example of a CDK source file that defines the infrastructure to run a Lambda function periodically. So how does it work? So the CDK has two main concepts, probably. One is the stack, that is similar to the CloudFormation stack. So you create a stack with all your resources. And then the idea is to create high-level constructs. So these high-level constructs are simplification of how you can create resources. So for example, if you want to create a Lambda function, you can use the Lambda high-level construct that is much easier to use than plain CloudFormation. It's designed by a person that tries to find the default parameters and how to use it. If you want to play with CDK, use an IDE like Visual Studio Code, because what is really cool with this approach compared to normal YAML files is that auto-completion from the IDE is super useful, because you create a Lambda function and you immediately see all the options that you have inside the Lambda function. And what we want to also help here with the CDK is to reuse components. So if you have a very large YAML file describing your infrastructure, if you want to reuse something, you have to cut and paste lots of lines. And this is error-prone, especially with YAML, because YAML is not delimited like JSON. So if you miss a line at the end, you will discover that only when you're in production, probably. Here you can define a high-level component in Java, in TypeScript, in Python, and then reuse that component inside another stack. So you create, and these are called constructs. So this is super useful. So here, for example, I say, okay, I want to create a stack. So I extend a stack. I want to create a Lambda function with all the parameters of the Lambda function. Then I want to create a CloudWatch event rule that is fired with this cron syntax that I think means Monday to Friday at 6 p.m. this function is triggered. So it's like a very traditional batch job. When the shop closes, you have to run some batch. And then here I add a target to the rule, and the target is the Lambda function. So in this way, every time this rule is triggered, the Lambda function is executed. So it feels very natural, and it's also much easier to write because the IDE will automatically complete everything for you. So this is infrastructure as code. The next step is automate deployments. So when you have your deployment pipeline, continuous integration gives you a feedback on the build, but continuous deployment gives you a feedback if your customers are using your product correctly. It's very important to do small deployments in production quickly and often, so that you can get a feedback often. Probably this is the most important metric that gives the speed of your development team. So how often and quickly you can deploy in production and get a feedback, of course. But the problem is, how can I be sure to deploy something in production without introducing bugs? So there's lots of practices here, blue-green deployments and canary deployments. But for example, how can I do a canary deployment for a serverless function? If I have 10 servers and I deploy one server with a different version of my code, then I can use this as a canary deployment. But if I have an abstract resource, a function, it can be more complex. That's why we introduced canary deployments as a feature of Lambda. So what happens is that you have your API, for example, if this works for every scenario with a Lambda function, and you have the version 1 of your code. What you can do, you can say, okay, I create a version 2, and then we integrated this with Code Deploy. It's our main deployment tool. And Code Deploy can do lots of things for you automatically. So first, can optionally run a pre-traffic hook. This is a function that does some check before any customer has access to the new version of your function. So the new version is deployed, but no one has still access, 0% access to the new version. You can run your own test. So for example, you can run some smoke test. You can have, for example, a synthetic transaction in production that you can run to check that everything works correctly. You can even run a performance test if you want, because this is a callback. So you can go outside of the 50-minute of the Lambda function timeout, because you have a callback that the Lambda function or someone else have to do back to Code Deploy to say, okay, go on with the deployment or not. So there's this pre-traffic hook we can check. Then, for example, you start to give 10% of traffic to the new Lambda version of the Lambda function, and you can check alarms. If there is any alarm, we roll back automatically. If there are no alarms, after maybe 15 minutes or some time that you define, all traffic is moved to the new version. And then we can run another hook, the post-traffic hook, and this is, again, your code that can do some final check before we complete the deployment. For example, one important thing is to annotate your Git repo that actually this commit is actually in production, because in a CI/CD environment, all commit go towards deployment, but as we just saw, some can be rolled back. So this is a good way to annotate, this is the version that I'm actually using in production. And this is automated. To do all these things, so to coordinate this deployment, you just need to add a few lines of code to the SAM template. So this is integrated with SAM, and there are similar options also for the serverless framework. So when you create a function, you just need to add a deployment preference. So for example, I want to do a canary deployment for 10% for 30 minutes, or I want to do a linear deployment so that for every minute, 10% of my customers are moved from the old version to the new version. You can add, it's optional, but it's suggested, alarms that we monitor during the deployment. So for example, if there is any error from my API, like a 500 error from my API, or if the latency of my API goes above a specific threshold, then we roll back the deployment automatically. And then you can optionally define the pre and post traffic hook functions that can do those smoke tests and final check before the deployment is completed. Just these few lines will automate everything that I was describing before, because it's integrated with Code Deploy. So when you automate deployments, the next step is, how can I know how to bring features in production quickly, but how can I evolve my software project in the right direction? So what I think is important, and it's something that we do a lot in Amazon, is don't think of what you're building as a project, because projects are statics. Think that you're building a product. So there's lots of interesting ideas around projects and products. I think projects force you to think into milestones. Now this is version 1 of my project. I want to release version 2. At the end of the year, I want to release version 3. It really forces you to think into major milestones. Products are different. When you build a product for your customer, you try to follow what your customer needs, and the customer need always change. So it's something much, much more dynamic. Project force you to think about how to reach the next milestone, how much time and effort I need to reach the next milestone. Product force you to think about how I can create value for my customer, and also force you to think into the life cycle of the product, not of the project. So if I build a car, the problem is not just building a car, it's building a car that is where you can find replaceable parts for 10 years, and if you have some issues, someone can solve those issues for this car for at least 10 years. And I think we should have the same approach for software products that we build. So we should think about what will be the life cycle of what you're building. So project really forces you to think about milestones and look backwards, while product forces you to think about what you're building and the life cycle of what you're building. And there are 4 main reasons why you change and update a product. You want to add new features, you want to reduce defects and bugs, you want to reduce risks, like security risk, or you want to reduce debt, like technical debt. And there's different teams inside your company that gives you feedback on which one thing you have to do. What is very important and sometimes is missing, and it's not easy to have, is a big link between your customer and the business to drive the new features, so that you don't add features based on some ideas, but really based on the feedback that you get from your customer. And even if you have 1 million of customers, don't use only reports and statistics. Try to have always a direct connection with your customer. We try to talk with, directly with as much as customers as we can, because direct connection is always different than the statistics that you can collect, and that can be interpreted in different ways. And since this is very dynamic, it's not a project management approach. We're not building a bridge in 3 years. We're building something that every few weeks we change direction because we get a new feedback. Avoid over-utilization of your team. You can't over-plan everything. So probably you need to leave 20, 30, 40% of your team time available for getting new feature and new feedback and reacting to the feedback that you get. And even if you do all of that, still be prepared to big failures, because this is the only way to innovate. So this is the letter that we sent to our shareholders to reassure them that having shares from Amazon is good, and we tell them it's good to have shares of Amazon because we are the best place in the world to fail, because we think that failure and invention are intertwined, so you can't innovate if you don't have big failures. So for example, just to share a few failures that we had in Amazon, maybe only the older of you will remember, but there was an Amazon auction website that was launched lots of years ago to compete with eBay. It was a big failure, but we learned a lot, and from that experience we created the marketplace that we now use for third-party sellers on the Amazon retail side. You may remember the Fire Phone from Amazon, another big failure, but we learned a lot about how to create physical hardware products, and we used that experience to build the Amazon Echo and now the Amazon Alexa platform. So big failures are not nice by themselves, but can help you improve. And for product development, there's lots of good advantage in using serverless, because you write less code, you are faster, and you can focus on what you want to build. With serverless, you can estimate the cost of your users per feature. So if you build a feature that makes your customer upload a picture to S3, and then you analyze this picture with some tool, you can really get the cost and say, okay, for every customer doing that, they will pay 0.002 cents. And then you can use this to build your business model in a much more refined way. So as a product development person, not just software development, you can really understand what you can put in a free tier, what requires to be paid because it's expensive, how much your users will cost of pure infrastructure for you every month. And it's so much faster to build an idea into a prototype. And since you have all this scalability and availability built in, it's also easier to build this, to bring these prototypes in production if they are validated and you want to go in production. And another interesting idea, and I will come back to this, is that if you use fully managed services, when we as AWS add new features, you can use these features very quickly, and your product gets automatic features with almost limited or very limited focus on your side. And I will come back to this later. So the next step is how can I make a product that is evolvable? So I think microservices are really important, and also an event-driven architecture that is natural with serverless is really interesting. So why microservices? Sometimes, more recently, I hear people saying, hey, I want to go back to monolith because microservices are too complex to manage or stuff like that. I think complexity is really an important way to look into this topic. So complexity is actually now a science that has been developed in the latest 20 years, that is a science going across mathematics, physics, biology, social science. And one thing that we found across all these different fields is that when there are dependencies among the components of something, this creates complexity. Normally, you get emerging behavior that you wouldn't expect. And I think this is the same problem that we have with a large code base. If you have a very large code base, it's very easy that at some point you take a shortcut and you connect one part to another, and then this will create a side effect maybe when you launch a feature 6 months later. So microservices really help you to create these small boundaries, and then inside the boundary you can do whatever you want, but you have a standard interface that allows you to limit these dependencies across your code base. And this is also something that was investigated in the 70s. This is John Gall. This is the book that created what we now call system theory. And in this book, he wrote this sentence that is now referred to as the Gall's law, that says that you can create a complex system from scratch. Every complex system that works needs to start as something simple, and then you have to add features. I think this is a corollary of what we saw before, but I think it's a very nice way of looking at things. And you really need to start with something working and then add features. And this works at any scale. For example, when we launched Amazon S3, this was the first service that AWS launched to be generally available in 2006. We launched S3 with a minimal feature set. And then over these 13 years, we added features based on the feedback of our customer. So think of this approach. Don't try to start with something too complex. It really just doesn't work. So why events also are important? Because with serverless, we have these fully managed services with storage, database, machine learning services that can analyze pictures, for example. And then we have functions. Functions is what can put your unique business logic and connect your unique business logic with those services. We were not talking about serverless when there were only fully managed services like S3 or DynamoDB. When Lambda was launched, people started to think, oh, now we can build serverless applications. And how do these services and this function talk together? They talk together using events. So if, for example, a user uploads a picture, and then this fires a function that will analyze this picture, or customer data is updated in a database, and this fires a function that will process this new information. Or you get just an API call, or maybe if you have a stream of data, there is an anomaly, and we detect an anomaly in the data, and this fires your business logic with your function. And function can call other services, creating nested and really interesting event-driven architecture. So, but what is an event? Why events are important when we build software architecture? If we look into the dictionary, an event is something that happens. And I think it's really interesting to think that events, like a customer upload, a database update, really tell us a fact that is also immutable. Because if something happens at this moment in time, like a new customer order has been created, this is an immutable information. Maybe this order will be canceled in 5 minutes, but this is another event. The event that is something is happening now is an immutable information. And immutable information is really useful in distributed architecture, because immutable data is much easier to use in a distributed architecture than something that can be continuously updated. So think of events as an immutable time series that you can process and operate. So of course, this opens lots of ideas, event sourcing, these kind of things. I don't have time to enter into that now, but think of events are probably something really important for your architecture, because normally we focus a lot in the current status of our system. So we create like a domain model of my warehouse, of my e-commerce shop, and we think about commands and control. No? This is my website, create a user, add a product. If you think of events, you think about what is happening with your application, about the events of your domain. So a user has been created, a product has been added. It's a completely different approach to the way you want to communicate between the environment and your application. And it's really, this is a traditional comparison between when you program a command-driven approach and an event-driven approach. But it's really interesting to think that if you think of APIs, for example, APIs are commands, and they have an intent. Create a user. You need to create a user. It's a targeted, almost personal communication. I can ask you, please create a user. It's one-to-one. But if I say a user has been created, I'm talking to all of you, and maybe not just you, but maybe other people is interested in the fact that this user has been created, and maybe they can use this information to do something. So inside a company, this helps create autonomous microservices, because I say, hey, a new user has been created, and maybe a new anti-fraud system that is created 1 year after will take this information and start to do anti-fraud check on the user without having to create strict coupling between the creation and the analysis of the user. And this also, this event-driven approach is also interesting going into areas like antifragility. So this is an interesting book. It's an economy book, not an IT book, by Nassim Taleb. He is introducing the concept of antifragility. And if you think, for example, of our immune system works very well because it continuously gets micro-infection. It solves this micro-infection, and it learns. So when we get a major infection, we can react. Can we use a similar approach for applications? Actually, in hardware and software architecture, there's a similar approach. It's chaos engineering. But the idea is, instead of seeing failures as a problem of an application, like an hardware failure or a software failure, we should think that at scale, a failure will always happen. Because when there's time and lots of moving parts, something will break. Can we do things that automatically react and improve by failure? So chaos engineering is a way of, for example, injecting controlled failure to check that everything works, and the short way of seeing that is breaking things to make things better. And also with microservices, it's important to understand latency, because often with serverless function, I hear people, hey, this function is slow, this function is fast. Speed is very relative. I love this table from this Brendan Gregg book, because it gives us an idea of the speed if you're inside the CPU, if you go into the main memory, if you go into the internet, if you use a solid-state disk, if you use a rotational disk. And just to give you an idea, now if one CPU cycle was 1 second, reading from memory is 6 minutes. Going to the internet is years. Doing a reboot is millennia. So the speed is very different. And we have to understand which is the target that we need. And also, don't think of latency as something that you can just look and maybe take an average. Average is really bad for latency because it's really not telling you what your customer experienced. There is no average user. So the best way, and what we use in Amazon and in AWS, is to think of percentiles and P numbers. So a P number, it tells you the number of observations below that value. So P50 means that 50% of the latency that I am observing are below this value. P99, 99% of the observation of the latency are below this value. P100 is, of course, the maximum, because 100% of the observation are below this value. P50 is the median, statistically. The median is also the average only if the distribution is symmetric. But a latency distribution can't be symmetric, because you can't get negative latencies. So that's why average is not a good metric for latencies. So what you see here, for example, is that this specific API has a P90 of 1 second, a P99 of 5 seconds, and a P100 of 22, 23 seconds. There's a lot of diversity, but you also get a lot of information here. This is a real graphic from one of the API that we operate inside AWS. Can anybody give a guess of what API is this? It's not easy. It's auto-scaling. The way to scale EC2 instances automatically from one to multiple instances. And why you see so much diversity is because most of the AWS, the auto-scaling group from our customer have single-digit groups, but there are a few that have thousands or tens of thousands of instances, and that's why you see this higher API when you go to P99 and P100, because you get these almost outliers in your API usage. And also, it's very important with microservices and serverless function, particularly, to trace everything. There's lots of products in the open source world with partners. We also have X-Ray that can help you visualize the flow of your distributed architecture, trace down what is happening, why a database is low or not. And I also created a tool that can help you do this kind of design graphically. So I just want to show you super quickly. So you can go here, and I want to create a streaming analytics platform, and then you can design this streaming analytics platform. It's a tool that can help you design and think of how to build serverless architecture is open source in my GitHub account, and it's completely running in the browser, so you can just download it locally and use it. There is no backend dependency for this tool. And also, you remember the idea of nested applications that I was mentioning before with the Twitter example? We also created nested application for processing events. So you maybe process the events of your application with your custom business logic, but we created standard components that can help you store, backup, and analyze your events, and also to replay your events, so that if you build an idempotent architecture and you have a bug, you can replay your events and solve and analyze them again. We have a full sample application for an e-commerce website where you get commands on the left, then you process with some basic business logic the orders that you get, and then you can store, filter, analyze, and replay the events of your store using these standard components. It's in the serverless application repo if you want to have a look. Next step is focus on your team, and this is super important, so I will spend a little bit more time here. We have this approach in Amazon, this is our CTO, that the development team must be in charge of everything, from development to testing to deployment in production. Must be in touch with customers and get the feedback from customers. So how can we do that and be successful? We can create a huge team, 100 people, and we solve the problem, because 100 people can do more things than 10 people. There's lots of interesting perspective there, but I think one very big problem is that when you grow the size of your team, there's some problem in the communication. So for example, if you have a team of 3 people, how many communication paths there are? Question to see if anybody's awake. 3 paths. No, it's very simple. If I have 5 people, how many communication paths do I have? 10 paths, because the number of paths grows with the square of the number of people. So if you have 10 people, you have 45 communication paths. It's impossible to create a team of 10 people where everybody is a peer of the other. Automatically, you create subgroups, sub-teams that are completely outside of your control. So that's why in Amazon we have what we call the 2 pizza teams. The sweet number is probably 4 to 6 people, not more than 4 or 5 people, 4 to 6 people. This is a good team size. If you go past that, it's better to split this project into 2 products and create different teams. But when you have a team that is more like this, how can you choose the skills? Now, if you have 100 people, it's very easy to get all the skills that you need. If you have 4 people, how can you choose the skills? Well, to define how to choose the skills of a team, let's first look at what is the problem we want to solve. So if we want to move all the chairs from this room from one part to the other, this is a separable task. The more people we have, the more we can go in parallel. But if we want to create a software product, this is a complex task. We need all people working together, and we need different perspectives to solve the problem. So what I think we really need is to have as much as possible cognitive tools that can help us find different solutions. So this is a simple model that maps cognitive tools, so the knowledge that we have, into some formal way. No? It's a simplification, but it gives us an interesting perspective. So let's assume that I can do mobile development on iOS, backend development in Java, SQL queries, and so on. Let's give a letter to each cognitive tool that I own as a developer. And then, let's say I'm Adam. I have 5 major abilities, A, B, C, D, and E. This is just a model. But these models can help us understand how we can work as a team. Because let's say that I have these 3 people here, Adam, Betsy, and Carl. Each of them has their own unique experience and different cognitive tools that I am representing with letters because it's easier to read. And let's say that I want to create a team of 2 people, because it's easier to do visually, and I have to choose 2 people among the 3 people that I have available. So normally I would say, okay, let's take the best people, and this will give me the best team. I take Adam and Betsy, but if I look into Adam and Betsy, there's lots of overlap between their own knowledge. So the unique ability of my team is 6. I have to think of these cognitive tools as different ways I can look into a problem and find a solution. what is interesting, if I take the two worst people here, there's less overlap, and I get 7 different abilities. So this team, even if it's created in this way, has probably more chance of finding a different solution to a complex problem, because it's able to look from a different perspective, maybe from the backend, from the front end, from the data, from the API management point of view. So this is an example of diversity bonus. So, and as everybody knows, we need diversity in IT. Diversity gives us a possibility of finding solutions that otherwise we would not know. And this is a problem, for example, when we are hiring manager. If we hire people in our team, we normally look for people that resonates with us, and we hire people that are similar to us. And at the end, the team leader is just a superset of everybody he hires, and there's no diversity and no bonus, and then the team will not be able to create more and find better solutions. And it is even worse in some specific fields where you need to learn things in order. So for example, if I want to create a team that is doing deep learning for analyzing images coming from video cameras on the street, then probably there's 2 universities in the world that do that. This is the standard research. Everybody has the same background. So in this case, you really need to use some different approach and maybe look for people that is coming from different experience. So even if everybody is doing deep learning, I take someone that has a more statistical approach to machine learning because it can help us look at things in a different way. But this is really a problem. OK, so now I created my team. I chose the skill to have the diversity that gives me the bonus to find more solutions. How long should I take this team and use this team? Forever, because I finally managed to find the right people, or maybe if I do it too much, it doesn't work. So there's this interesting study that has been done in Broadway, where in New York, where they do the musical, and gives us hints of how teams work with creativity. This is a problem that normally in analytics is called the small world networks. There is a small network that of social relationship here. So someone took look into what 2,000 people did in 40 years, and they worked in 400 or 500 musicals, and they wanted to see how the team was working good or bad in this musical. So this study, they actually created a parameter that is called Q, and this Q for each team was studying how often this team was working together with the same person. So a low value of Q means this is a new team, they never worked together a lot, and they created a musical. And if a high value of Q means these people worked a lot in lots of musicals and created lots of musicals together. And then they look into the reviews and the revenues of the musical. That gives you a hint of how good was their work. These two are strictly related. And they did a graph. So what do you think it happened? So who here thinks that a low value of Q, so people never working together a lot, gives the best result? Few people. Who thinks that a high value of Q, so people working a lot together, gives the best result? OK, a few. Who thinks that an average value of Q gives the best result? OK, I see, yeah. And that's actually what happened. So a low value of Q is the worst, because people really need to discover how to work together, probably. But if you work together too much, I think there is the side effect that you start to fall into habit. You don't look into different things. You just repeat what you did together all the other times. So if you create a team, keep a core and rotate the team, plugging in and out a few people so that there's still new energy and that you don't fall into habit. And the last thing is really don't reinvent the wheel. So look for what other customers are doing. So this is, for example, Capital One, a huge bank operating in the US and the UK. They built one of the very few public APIs that they have, serverless. This is an API that they call the credit offer API that they use to advertise their credit card with those comparison websites that you use to compare websites, like compare offers, like this is the best credit card for you comparing these 12 banks. So this API is critical for them. They also start the registration process for new credit cards using this API. And they built it serverless, and they use the deployment automation that I was mentioning before. They have 2 deployments on the 2 coasts of the US, and they deploy with a canary deployment. Before moving to this architecture, they were deploying once per week, 2 a.m. on Monday. Someone from the team must be there. Now they deploy during working day with canary deployments, with automatic rollback. They deploy multiple times per day, and they're super happy. They actually see that there is 30% more time available in their team. And this is the same percentage that another customer, Dunelm, a retailer in the UK, told me based on the analytics that they did with their sprints. So basically they say, we are 30% more effective than we were before adopting serverless. We have more time to focus and build. Another customer that I love is Comic Relief. It's a no-profit organization in the UK. And one day, every year, they do a full day with the BBC, the public broadcaster, to raise money. It's when they raise 95% of their money every day. And their donation platform reached 350 donations per second. So a donation platform is like an e-commerce platform with no stock, because they sell just donation. And what is interesting is that it's very sensitive to the experience, because if you want to buy something and the website is slow, you may try again. But if you want to do a donation and you have some kind of struggle, you just forget and okay, I can do the donation, and you move on. So they must be very fast, quick, and give a good user experience. So during the month of this day, they needed to run performance tests. It was very complex and costly for them. 2015 was the last year they were completely without anything serverless, and it was costing this month for them $84,000 with all the tests and the day to run. Then they start to move small things, and this year they moved the donation platform to serverless, so they rebuilt the donation platform serverless using DynamoDB, Lambda, SQS, and other tools from AWS. And the bill went down to $5,000, but actually the serverless part here is just $92. Everything else is still the database and the other legacy stuff that they still have. So serverless was super efficient for them. But the most important thing is not the cost saving, but they say before we needed 2-3 weeks to scale up an environment and do some, if we need to run a new campaign. Now we could do it all again tomorrow without ending, because everything is serverless, ready to scale. So for them, this is a business change. If something happens in the world and they want to run a global scale campaign tomorrow to raise money, they can do it. Before, it was not possible for them. So I'm passing by the demo because I'm a little bit late. I just want to tell you that don't reinvent the wheel, but this is an iterative process. So all the steps that we saw today is something you need really to focus on. And probably the best way is, and this is one of the leadership principles that we have in Amazon, my favorite one, is learn and be curious. So if you're here at this conference, you probably have this attitude, but there's always something to learn. It's a really nice and dynamic environment, and serverless is really growing right now, so it's something that can get your interest. And if you're curious, these are a few of the books that inspired my talk. Thank you.